Welcome back to our Chapter 2 Basic Concepts of Derivatives and Their Applications. We are now in Section 2.2 Limit Definition of the Derivative. We have the following learning objectives. This is our targets. First is to find the derivative of a function using its limit definition, and next is to evaluate the specific derivative of a function at that number included in its domain. Here are the prior knowledge required. First is we must have the algebraic simplification techniques. Next, we have also techniques in the evaluation of limits, and the last one is the trigonometric identities. So those are the prior knowledge required to this topic. In the previous lesson, you have learned how to determine the slope of a tangent line using its limit definition. Now it will be appropriate to relate the said formula to the formal definition of the derivative based on the concept of limits. So we are now on this term formal definition of the derivative based on the concept of limits. So notice the similarities of this definition with that of the slope in section 2.1. And furthermore, you should be able to obtain the derivatives of functions using limits. And these rigorous computations can enhance your analytical and critical skills, and thus will prepare you for the more technical problems you will be facing at the tertiary level. Now we have the formal definition of the derivative of a function stated below. We have definition 2.2.1, limit definition of the derivative. The derivative of a function is the function f prime defined by f prime of x is equal to limit of f of x plus h minus f of x all over h as h approaches 0 if this limit exists. So kung imong tan-awon ang iyang definition is the same as the previous lesson. Nalay kalahian kamay, especially this f prime of x. So we have the following remark. The first one is, if the derivative is computed for a specific value c refers to a constant in the domain of f, then the x in the formula will simply be replaced by the c. That is f prime of c is equal to limit of f of c plus h minus f of c all over h as h approaches 0 if it exists. And this gives the derivative of f at the number c. Furthermore, such a derivative can be obtained using an alternative solution, the same as the previous lesson. Here, the alternative solution states that f prime of c is equal to limit of f of x minus f of c all over x minus c as x approaches c if this exists. Of course, you may opt to compute the general derivative formula first and then substitute the particular value of x, in this case, in the final answer. So we can use the first one, and we have the alternative also. Now for the second, notice that the formula in our definition in this section is precisely the formula for the slope of the tangent line to a curve y equals f of x at the point c and f of c as presented in section 2.1. So the same lang sila. Thus, the derivative of a function can be viewed as a means of getting the slope of a tangent line at any point x and f of x. And the last one, note that the process of getting the derivative of a function is referred to as differentiation. So take note where the word differentiation, that is the process of getting the derivative of a function. To differentiate a function means to obtain its derivative with respect to the independent variable. Other notations Commonly used to denote derivatives of functions defined by y is equal to f of x are the following. First, we have the y prime. This is the common. And we have dy over dx. We have dxy. We have dx of f of x. We have d over dx of f of x. So, the same lang sila og bot pa sa bot. These are used to denote derivatives of the function. When getting the derivative of a function at a number c, the corresponding notations to be used are the following. So, if c, ito yung gagamitin, f prime of c, y prime of c, y prime, and then x equals c, dy over dx, subscript x equals c. We have dxy such that our x is equal to c, and dx f of x such that x is equal to c. So, kani nga mga notations, usa lang denote nila. That denotes the derivatives of the function. So, let's have some examples. First, need to consider the function y is equal to fx, or f of x equals 5x minus 2, and then find its derivative. So, we need to apply the given definition. It states that f prime of x is equal to limit f of x plus h minus f of x over h as h approaches 0. So, man atong gamiton o na to find the derivative. Our f of x is equal to 5x minus 2. So here, just copy limit, and then copy 5. Tapos ang x, pulihan mo x plus h. Tapos minus 2. Mani ang kaning part. Sa next, we have minus. What is our f of x? That is 5x minus 2. All over h as our h approaches 0. Next is simplify. Limit. So 5 times x, we have 5x plus 5 times h, we have 5h minus 2. Here, we have minus 5x, and then we have positive 2. All over h as h approaches 0. 5x minus 5x, pwede na ito i-cancel. And kani negative 2 sod og 2. So, unsay remaining limit of 5h na lang over h as h approaches 0 equals. So, here, h over h, ito that is equals to 1. So, we got limit of 5 as h approaches 0. So, what is the limit of 5? The answer is 5. Thus, our f prime of x is equal to 5. Okay, so inanalay buhaton, we need to apply the definition on this section. And then, pag abot diri ang kaninga expression, 5x minus 2, since diri is x plus h, ang x pulihan og x plus h. Then, copy minus 2. Then, minus our f of x, here, klaro, ang atong f of x is 5x minus 2 over h as h approaches 0. Then, simplify. Then, ang remaining nato nun a limit of 5 as h approaches 0. We know the limit of a constant number is the constant itself, so we get 5. So, that's why here in this example, our f prime of x is equal to 5. Number 2, given the function defined by y is equal to f of x is equal to 4 minus 3x squared. find f prime of 2. So we have f prime of x is equal to limit of f of x plus h minus f of x all over h as h approaches 0. So that is the definition on this section. Okay, since we have f prime of 2, so we get f prime tapos ang x pulihan of 2 is equal to limit f of x is 2 plus h minus f of 2 all over h as h approaches 0. So from here, now we can apply this expression. So we got limit. So we have 4 minus 3. Now our x, pulihan na to 2 plus h raised to the power of 2 minus f of 2. We got 4 minus 3 times 2 raised to the power of 2 all over h as h approaches 0. Next, simplify. Limit. We get 4 minus 3. So take note, 2 plus the square of 2 plus h is can be written as 2 plus h times 2 plus h. So we get 4. We got 2h plus 2h plus h squared. We get 3. So 2h plus 2h, we get 4 plus 4h plus h squared. So we get 4h plus h squared minus. So we got the square of 2 is 4. 4 times 3, so we got negative 12. So 4 minus 12 all over h as h approaches 0. Next equals limit of 4 minus 3 times 4, 12 minus another 12 na pod, 12h minus 3h squared. 4 minus 12, we got negative 8. We got plus 8 over h as h approaches 0. Next, simplify further. Limit. We got 4 plus 8, 12. 12, positive 12 minus 12, that is 0. So, ang naibili na lang is negative 12h minus 3h squared over h as h approaches 0. And then, limit. We have a common of h. Negative 12 minus 3h over h as h approaches 0. So, cancelled. So, ang sa'yo na maibilin is limit of negative 12 minus 3h as h approaches 0. Now, we can apply the limit. So, we have negative 12 minus 3 times 0. So, the answer is negative 12. So, thus, f prime of x, f prime of 2 rather, is equal to negative 12. So, that's it for our second example. Given the function defined by y equals f of x equals 4 minus 3x squared, and find f prime of 2. Next is determine the derivative of the function defined by y equals 2 over x squared. Then find y prime 2. In this example, we need to determine the derivative of the function defined by y equals 2 over x squared, then find y prime of 2. So the same, we need to apply the definition in this section. We have f prime of x equals, we have limit of f of x plus h minus f of x over h as h approaches 0. So take note, here we have the y prime or the derivative of y. So here we have f prime of x. So we have y prime equals, so limit of f of x plus h minus f of x all over h as h approaches 0. So next, equals limit. So here we have 2 over x squared. So we have 2 over, instead of x, pulihan na to siya x plus h square minus our f of x. So we have 2 over x squared all over h as h approaches 0. Okay. Next, limit. Get the LCD sa numerator kaning part, which is x squared tapos the square of x plus h. So here x squared times the square of x plus h divided by the square of x plus h. The remaining is x squared times 2. So we have 2x squared. Next is minus x squared times the square of x plus h divided by x squared. The remaining is the square of x plus h times 2. So we got 2 times the square of x plus h all over h as h approaches 0. Next, simplify. Limit the square of x plus h. The result is, so the square of x plus h, that is x plus h times x plus h. So you get x squared plus hx plus hx plus h squared. So we have x squared plus 2hx plus h squared. 2x squared minus 2 times x squared plus 2hx plus h squared over x squared times the square of x plus h all over h as h approaches 0. Simplify. So limit 2x squared minus 2x squared minus 2hx minus 4hx rather, since we have 2 times 2, then minus 2h squared over x squared times the square of x plus h all over h as our h approaches 0. Simplify. Ito, tanggal na. 2x squared minus 2x squared, that is 0. So the remaining is limit of negative 4hx minus 2h squared over x squared times the square of x plus h over h as h approaches 0. So reciprocal lang. We get limit of negative 4hx minus 2h squared over hx squared, the square of x plus h as h approaches 0. And then find the common, which is h. So h, negative 4x minus 2h over h x squared times the square of x plus h as h approaches 0. Tanggal. So, limit is equal to negative 4x minus 2h all over x squared times the square of x plus h as h approaches 0. Next, we have limit of negative 4x minus 2h. Ang sa ubos, x squared times the square of x plus h. The result is x squared plus 2hx plus h squared as h approaches 0. So, simplify pa, equals limit negative 4x minus 2h over x to the fourth power plus 2hx cubed plus h squared x squared as our h approaches 0. Equals, substitute na nato yung h nato which is 0. So, negative 4x minus 2 times 0 over x to the fourth power plus 2 times 0 times x cubed plus the square of 0 times x squared. So, the remaining now is negative 4x over x to the fourth power. Simplify, we get negative 4 over x cubed. Papatanahuman, isubstitute nato karon ang atong 2. So, y prime of 2 is equal to negative 4 over x cubed. So, negative 4 over, what is our x? That is 2. 2 cubed. So, negative 4 over 8. So, the final answer is negative 1/2. That is y prime of 2. Now, we have the fourth example. Determine dy over dx such that x is equal to 4 given that y equals 3 times the square root of 5 minus x. So, now, we may apply our alternative definition. F prime of c is equal to limit f of x minus f of c all over x minus c as our x approaches c. So that is our alternative definition. So applying this alternative definition, we get equals limit. So we have f of x, we get 3 square root of 5 minus x minus our f of c. Take note our c is 4. 3 square root of 5 minus 4 all over x minus c. So x minus 4 as our x approaches 4. Next, limit 3 square root of 5 minus x minus, so 5 minus 4, that is 1, square root of 1 is 1, 3 times 1, that is 3, over x minus 4 as our x approaches 4. So here we can see a common, which is 3. So we got limit of 3, 5 minus x minus 1 over x minus 4 as our x approaches 4. So, pwede na to ilahi ang 3 diri according to the previous chapter, di ba? So, we got 3 limit of square root of 5 minus x minus 1 over x minus 4 as our x approaches 4. So, next, we can multiply this one, a radical, by square root of 5 minus x plus 1 and square root of 5 minus x plus 1. So, the result is 3 limit of 5 minus x minus 1 over x minus 4 times square root of 5 minus x plus 1 as our x approaches 4 equals 3 limit. So 5 minus 1, that is 4 minus x over x minus 4 times square root of 5 minus x plus 1 as x approaches 4. So here, 3 limit. Take note, we can rewrite 4 minus x para makaparehas sa x minus 4 as negative x minus 4 over x minus 4 times square root of 5 minus x plus 1 as x approaches 4 equals cancelled na hibilin sa ibabaw is negative 1 over square root of 5 minus x plus 1 as our x approaches 4. Okay, next equals 3 times the limit. We have negative 1 over square root of 5 minus 4 plus 1 equals 3 times negative 1 over 5 minus 4, that is 1. Square root of 1 is 1. 1 plus 1 is 2. So we got negative 3 over 2. Now we have the fifth example. Prove that dx sine x is equal to cosine x. So atong i-prove siya. The first definition, f prime of x is equal to limit of f times x plus h minus f of x over h as our h approaches 0. So since we have sine x, so from this definition, atong i-derive using this one. So we have d of x sine x equals limit. We get x plus h. So we have sine of x plus h minus sine x over h as our h approaches 0. Then applying the identities, so we got limit. So here, pwede tayo maka-apply og identity. So we have sine x cosine h plus cosine x sine h minus sine x over h as our h approaches 0. Okay? So, ang identity ani, we have this one. Next, limit. Ito lang itapad ang mga sine x. Cosine h minus sine x plus cosine x sine h over h as our h approaches 0. So here we have the common na. So we can factor that one. Limit of sine x. So we got cosine h minus 1 plus cosine x sine h over h as our h approaches 0. Next, atong buwagon. So we got limit of sine x cosine h minus 1 over h as h approaches 0 plus limit of cosine x sine h over h as our h approaches 0. So applying the previous theorem, the previous chapter, we can use this one para makuha na to ang answer. Equals. So para ma-usob ni nga masold siya og 1 minus cosine h. So, tanggalan na to ang negative. Okay? So, tanggalan na to ang negative, tapos ang sine x. We got limit. So, ang mahibilin diha is positive 1 minus cosine h over h plus limit. So, as h approaches 0. Next, here is tanggalan po na to ang cosine x. So, we have cosine x. So, nahibilin limit of sine h over h as our h approaches 0. So, we can apply now the limit theorem. So, negative sine x. So, the limit theorem here. So, 1 minus cosine h over h as h approaches 0 is 0. Plus cosine x. And the limit of sine h over h as h approaches 0 is 1. So, equals negative sine x times 0, 0. Cosine x times 1 is cosine x. So, that is the derivative of sine x. So, that's it. And the last example, we have find dx sine x, derivative of sine x, such that x is equal to pi over 4. Take note sa itong previous example, example number 5, that d of x of sine x is equal to cosine x. Now, ato lang pulihan ng x o pi over 4. So, cosine of pi over 4. Using the table, pi over 4, you can convert this one into degree. So, we got 180 divided by 4 is 45. And then, kung imong tanawon sa table, ang equivalent is square root of 2 over 2. So, that is the final answer. So that's all for our section 2.2, limit definition of the derivative.